What we're doing in this second part is we're going to think about how all of these hormones, so the GnRH, the LH, the FSH, the estrogen, the progesterone, and others, how they regulate both the ovarian cycle, so the development of the follicle, how the follicle changes after the egg has been released, but also how they influence the uterine cycle, so how the uterus is developing in preparation for implantation and pregnancy. So again, we are going to make a very crude presumption because it just makes teaching easier that the human female cycle lasts about 28 days and it's 14 days on each side. Now, in the two parts of the phases. Now, that is not particularly accurate, okay? The luteal phase is relatively constant, okay? So most women will have a nice 14-day luteal phase, give or take. But the follicular phase can vary quite widely, okay? So it can go from 10 to 20 days or longer. So that's the phase that can change. So as is shown in this little diagram, the beginning of the cycle begins with menstruation, okay? And that's, as we'll think about later, is because estrogen and progesterone levels have dropped, and therefore the endometrium, remember that's the uterine layer, that can no longer maintain itself, or no longer be maintained is a better way of putting it, and so it is expelled and it is lost. So the fluid in the tissue is lost. And because the estrogen and the progesterone levels dropped, we then move into the follicular phase, so the development of the follicle. So that's the first part of the cycle, okay? It is dominated by the presence of maturing follicles, and those maturing follicles produce estrogens, and those estrogens have an effect. One, they further activate the follicle or stimulate it to mature even further, but they also inhibit what's going on at the level of the anterior pituitary and hypothalamus, as we'll talk about in a second. So they kind of inhibit LH and FSH production, FSH in particular. So when the end of the follicular phase hits and the egg is nice and mature, the egg is released, okay? And that's the kind of what's happening in between the follicular phase and the luteal phase. So the luteal phase is that second half of the cycle. And that is characterized by the presence of the corpus luteum. So you remember we had a nice follicle that formed in the first part of the cycle that released the egg. Well, you've got all those cells that are left in there. That whole structure is left. And a hormone that we'll talk about in a second causes that follicular remnant, the remains of it, to turn into another structure, the corpus luteum. And that corpus luteum then takes up lots of cholesterol because cholesterol is the precursor for progesterone and estrogen, but we're producing lots of progesterone in the second half of the cycle, or the luteal phase of the cycle. So we're getting the corpus luteum producing progesterone and estrogen. And the corpus luteum lives roughly about 7, 8, 9, 10 days under normal if pregnancy does not develop. And after that amount of time, it starts to degenerate and die. And as it can't, therefore, produce progesterone and estrogen, you get rid of inhibition that's occurring. So progesterone and estrogen drop, and you go into that menstrual phase, and then menstruation occurs, and we move back into the follicular phase. So we have this nice little cycle. Now, I've kind of explained some of the things that are going on. And it might not make sense because you can't see what actually each hormone is doing at any one point. So that's what we're going to do after this. So we're going to kind of think about how the hormones are driving both the follicular phase, the egg being released, the luteal phase, but also how their withdrawal starts to stimulate menstruation. So that's what we're going to do in a second. As always, we've got a review question first. So I'd just like you to, again, press pause, read the question, think about the answer, and then I shall give you the answer. Okay, so a 24-year-old woman has regular 28-day cycles. She is most likely to ovulate at which transition? So hopefully you said at the end of the follicular phase. So remember, follicular development, follicle is fully developed, egg is released. So that's ovulation. And then we move into the luteal phase. Okay, so we are now going to think about follicular development. So remember, this is near, or in terms of the ovarian cycle, this is what's happening initially. So if we're just looking at the hormones here, so up at the hypothalamus, we've got lots of stimuli coming in at the hypothalamus. some of them activating, some of them inhibitory. So remember, we talked about that. So your weight, whether you lost weight rapidly, you're doing a lot of exercise, there are all manner of things that are coming in, the stress levels that are influencing our hypothalamus. Presuming everything is normal, which we will presume at this point, the hypothalamus stimulates the release of GnRH, okay, in that pulsatile way that we've talked about. The GnRH moves through blood vessels to the anterior pituitary, and in the anterior pituitary, it stimulates the release of FSH and LH. So LH doesn't really have much of a role at this point, okay? So we're just going to focus on FSH, hence from its name, follicle stimulating hormone. So that follicle stimulating hormone goes through the blood supply to the ovary. And at the ovary, it starts to stimulate about 15 to 20 follicles. So we've got lots and lots of follicles developing at this point, okay? Lots of them going. And as these follicles are developing, they are producing a couple of hormones, one of which is inhibin. Okay, and this is being produced in males as well. So one is inhibin, and that inhibin, as you follow it through, goes back and causes negative feedback on FSH. So what we've got is FSH coming into the ovary, stimulating the follicle's producing inhibin, which is then inhibiting FSH. At the same time, this follicle, as it's developing, is producing estrogen. And at moderate estrogen levels, that estrogen has a positive feedback loop or a positive feedback effect on the follicle. So as the follicle develops, it produces estrogen. The estrogen then goes back to the follicle, helps its development, and you get this positive feedback loop occurring the whole time. As well as estrogen at this level, helping to stimulate follicular development, it's also inhibiting both FSH secretion and at the level of the hypothalamus. So really, as the follicle develops, the levels of FSH start to drop. And that's a very important thing to keep in your head. Because remember, we had 15 to 20 follicles developing. But the reality is, in most cases, only one follicle develops fully towards the egg being released and ovulation. And so because the FSH levels are dropping during the first part of this cycle, the falling FSH essentially eliminates weaker follicles. And the reason only one follicle survives is it's the one that has the most FSH receptors. So it can keep growing even when FSH levels are low. And so this is the one that becomes the dominant follicle. And all the other follicles just die. They don't have enough FSH receptors. They haven't had enough opportunity to grow. Okay, so remember what's happening in the first half of the cycle. GnRH stimulates FSH, stimulates the ovary and follicular development. The follicle itself produces inhibin and estrogen, both of which inhibit FSH. Therefore, because FSH has dropped, only the strongest follicle keeps developing. And that follicle is producing estrogen, which again is helping in its own development. Okay, and you can see here's a picture of a follicle. You can see the egg with its surrounding zona pellucida. Okay, so that's just the zone around it. And you can see the antrum, which is fluid filled, okay, and then the different types of cells that have got different functions that you really don't need to worry about. Okay, so what we've got here, we've got a follicle that is developing very nicely. After about 14 days, the egg is now ready. The follicle has fully developed. And so here it is. You can see the egg has moved to one side. You can see the antrum. You can see it's got a lot larger and the pressure is actually a lot greater in there. And we'll think about why that is in a second. But the greater pressure in there is helping to force it to the side. So, same diagram, okay? So hypothalamus, GnRH, FSH, but now we have got a mature follicle. So the follicle is ready. We're ready to release the egg. Inhibin still being produced, inhibiting FSH. But now what we've got, the follicle is lovely and ready, and we've now got very high levels of estrogen. And it's those very high levels of estrogen that now, instead of having a negative feedback on FSH and hypothalamus, they now have a positive feedback effect on LH and on the hypothalamus. So by stimulating the hypothalamus, they produce GnRH and lots of LH. but also we're stimulating directly the LH secreting cells to make even more LH. And so that luteinizing hormone means increases rapidly to cause an LH surge, as it's called. So you get a massive spike in luteinizing hormone levels, and that luteinizing hormone surge causes ovulation. Okay, so it's the LH surge that leads or triggers ovulation. So what I'd like you to do, have a little look at this review question. Ignore the part on the right-hand side, so ignore the hormone changes, if you like. But just have a look at the review question and then press pause, and then we'll go through it. Okay, press pause. So a woman uses ovulation predictor kits that detect a hormone surge at ovulation. Which hormone is being detected? So we literally did it in the last slide, so I'm hoping everyone has said LH, so luteinizing hormone, which is D. So what I would like you to do also is on the right-hand side, you've got a kind of an image showing hormone changes and follicular development and ovulation. What I would like you to do is just think about what is happening during this follicular phase. Remember, it's called the follicular phase. What is happening with the hormones and what is happening with with follicle development. So again, press pause and have a good think about what is happening. Okay, I'll go through it very, very crudely, very, very simply. So, beginning of the cycle, we get an increase in FSH. That follicle stimulating hormone causes the follicle to start developing. The follicle, one of the hormones, so it produces inhibin, as we know, but it also produces estrogen. The estrogen inhibits the production of FSH, so FSH starts to drop, but it also stimulates the follicle to develop. So the follicle keeps developing and developing and developing until we get a huge amount of estrogen being produced. And at this huge amount of estrogen, it has a positive feedback loop causing an LH surge. So FSH goes up as well because remember, estrogen stimulates GnRH. But it's the LH surge that does the work. That LH surge causes weakening and breakdown of the follicle wall. So basically, it's done via enzymes. It stimulates enzymes that break down the follicle wall. It increases the follicular fluid pressure, which helps to force the egg out during ovulation. And so these changes leads to rupture of the follicle, releasing the egg from the ovary and therefore and into the fallopian tube, leading to ovulation. And so then at this point, we've got a follicle without the egg. And so this is now called your follicular remnant. You can also see at this point, there's a massive drop in estrogen, okay? And that's because the follicle is only a remnant. So it's no longer in a state to be able to produce high levels of estrogen. So remember what we said. We had rising levels of estrogen. That stimulates a surge of LH. So that's a positive feedback loop. That surge causes follicular rupture and the release of the egg from the ovary, and that's your ovulation. And like I said, you've got this follicular remnant that is left. So what happens though? These old follicular cells now undergo a dramatic transformation. Okay, and they do this in both their structure and function. And they basically form a structure called the corpus luteum. And this corpus luteum appears kind of yellowish because of the high amount of steroid hormone precursor there. So that's cholesterol. Remembering we just had ovulation, this, if you're ever looking to become pregnant, is round about where fertility is at its highest, in the days around ovulation. So in our luteal phase, we have now formed the corpus luteum under the influence of luteinizing hormone. So it's luteinizing hormone that has driven the formation of this corpus luteum. And this corpus luteum is maintained, so kept alive again by the presence of luteinizing hormone. So it's very important. Luteinizing hormone keeps this corpus luteum alive. So if luteinizing hormone levels drop, the corpus luteum starts to regress or start to die. We've already said this. The ruptured follicle forms the corpus luteum, which releases large amounts of both progesterone and estrogen. Remember, it's yellow because of cholesterol, and the cholesterol is the precursor for both progesterone and estrogen. So they are steroid hormones. Remembering what we also said, that luteinizing hormone maintains the corpus luteum. It keeps it alive. What is the corpus luteum doing? Well, like we said, it's making progesterone and estrogen. So it's essential for establishing and maintaining a pregnancy because the estrogens, as we know, are responsible for endometrium thickening. Uh, so the uterine endometrium thickening, but progesterone is dominating after ovulation, and it's allowing further endometrium development and maintenance. But the key thing at this point is it is inhibiting LH and FSH. So the corpus luteum is producing high levels of progesterone, and that progesterone is inhibiting LH and FSH. And remember what happens, it is LH that keeps the corpus luteum alive. So the corpus luteum produces progesterone. The progesterone inhibits LH, so therefore LH levels drop, meaning the corpus luteum will die unless fertilization takes place. So if the released egg is not fertilized and doesn't implant, the corpus luteum degenerates about 10 days. And like I said, that's because luteinizing hormone levels drop. And as the corpus luteum degenerates, estrogen and progesterone levels drop. That is the end of your luteal phase. And now, because there is no progesterone there, FSH is no longer inhibited, so the whole cycle can start again. Okay, review question. Press pause. A woman has just ovulated. Which hormonal change now dominates her cycle? Hopefully, you have put B, rising progesterone secretion. What's the name of the structure? Corpus luteum. What hormone keeps the corpus luteum alive? Luteinizing hormone. Okay. So, last little bit, I think, from memory. We are going to think about endometrium development. So that's the uterine lining we're thinking about. First, we'll have a little think about the cervical mucus. We did mention it a little bit earlier when we talked about the functions of estrogen and progesterone. But now you know when estrogen and progesterone levels are actually at their peaks. So when you have high estrogen levels just prior to ovulation, this causes the cervical mucus to become really clear, thin, and abundant in this kind of egg white-like pattern. And that allows or facilitates the passage of sperm through the cervical canal. Progesterone, which is taking place in the second half of the cycle, or the luteal phase is a more accurate way to think about it, causes the mucus to become thick and sticky, and that plugs the cervical canal. And that cervical plug is an important defense mechanism because it prevents bacterial entry into the uterus from the vagina. And that obviously prevents bacteria entering that may threaten a possible pregnancy. It also prevents sperm penetration. You don't need sperm getting through during that luteal phase because the egg does not live long enough. It's only got a 24 to 48 hour lifespan. So there's no point sperm getting through at that point because there is no viable egg there. So when we're looking, so we'll go on to the endometrium now. So remember, that's the uterine wall. And so this, if we're looking at this image, first of all, this is your time span. Remembering we're just presuming a regular ballpark average 28-day cycle. Remember, that's not the case for a huge number of people, but it's a good one in terms of teaching. And this on the y-axis is just thickness. So this would be in millimeters from 1 millimeter up to 5 millimeters or so. Okay, so if there were labels there. And the phases of endometrium development are separated into the menstrual phase. So you can see the loss of tissue, the proliferative phase. So that's when that's in the first part of the cycle, first phase of the cycle, which is your follicular phase. And that's when you're getting endometrium thickening under the influence of estrogen. Then you go into your secretory or progestational phase. So this is where you're under the influence of progesterone. And then you go into the new menstrual phase, which is where you get breakdown of the tissue and the whole cycle begins again. So we're just going to go through each of those in time. So we're thinking initially the menstrual phase. Okay, so this is where you're getting menstruation, obviously. So this is where your progesterone and estrogen levels have dropped. And so the dropping of those progesterone and estrogen levels causes an increase in the release of uterine prostaglandins. Now, prostaglandins do lots and lots of their molecules that do lots and lots of different things. Okay, and we've covered them elsewhere already. But these prostaglandins, they cause endometrial blood vessel vasoconstriction. Now, we've talked about what happens with vasoconstriction. If you vasoconstrict blood vessels, they start to become hypoxic. And if they start to be, the tissue beyond them starts to become hypoxic. And so therefore, that hypoxia leads to death of the endometrium and blood vessel rupture. So immediately we're thinking, okay, so this is why the endometrium is going to start to die. It also stimulates myometrium, so that's uterine muscle contractions. Those contractions obviously help to expel that dead endometrium and the blood, and so that's your menstrual phase, your menstruation. And that can be anywhere from 20 to 200 mils. So it can be very, very variable. So very variable in different people. But of course, you've got those myometrium, those smooth muscle contractions in the uterus. So sometimes people, if you get excessive contractions of those, that can lead to those what are called menstrual cramps, okay, that some women experience. So we've done your menstrual phase. So we've done this first phase where basically there's a drop in estrogen and progesterone, the uterus can't be maintained, and we get breakdown of the tissue and the tissue is expelled. We then have the proliferative phase. So remember, this is where we're getting high levels of estrogen being secreted by the developing follicles. This, therefore, stimulates growth and thickening of the endometriums, that's the tissue bit, and the myometrium, which is the smooth muscle underneath the endometrium. It also stimulates the synthesis of progesterone receptors. So we're kind of going, right, we're going to get the uterus ready for the progesterone as well. So it's priming the uterus for that progesterone that's going to be secreted in that luteal phase. And that thickness that we've talked about has now gone up from 1 millimeter up to 5 or 6 millimeters at this point. Okay, so the uterine glands within the endometrium are now developing, but they aren't at this point producing anything. We then have a little bit of flatlining at about day 14-ish in a regular 28 equal cycle, if we think about it like that. So you get this little equalization. That's when the corpus luteum is forming, so you get a drop off in estrogen before it kicks in again when we get into the luteal phase. So we've now, at this point, we've gone on, we've now formed the corpus luteum, remember, under the influence of luteinizing hormone, and we get lots of progesterone and estrogen now being produced. But it's really the progestational phase, so lots of progesterone being produced. So with this, the progesterone does lots of things, one of which is to stimulate the uterine glands that formed in the follicular phase to secrete uterine milk. And that milk is high in protein, high in glycogen. And that provides the nutrients should the egg become fertilized. So it's providing lots of nutrients there ready for egg development. Okay, so we'll have another little question just to make sure you're all with us. So press pause. A fertilized egg reaches the uterus. Which uterine state is most suitable for implantation? So hopefully you wrote secretory endometrium under progesterone. So the progesterone is causing the endometrium to release these nice fluids. So this uterine fluids, uterine milk, high in glycogen and high in proteins to help to feed the developing ball of cells. Okay, so last phase, new menstrual phase. So if fertilization doesn't occur, the corpus luteum dies. Remember, why does it die? Why does it die? Because the progesterone that is being produced during the luteal phase is inhibiting luteinizing hormone. Luteinizing hormone levels drop to such a state that the corpus luteum isn't maintained. Therefore, progesterone levels start to reduce and estrogen levels start to reduce. So the endometrium can no longer be maintained and death occurs, or necrosis. And then we expel, that's all expelled with blood and tissue as that menstrual fluid, lasts a few days, as we've already said, and anywhere between 20 and 200 mils is lost. And then because progesterone levels and estrogen levels have reduced, they are no longer inhibiting FSH and LH, so they can start to rise again and the new cycle begins. So here is a cycle of what's happening in the ovarian cycle and the uterine cycle as well, I guess, is what I want you to be thinking about. So what I'd like you to do is have a look at this image and summarize in your head exactly what is happening with the hormone changes, in particular, thinking about estrogen, LH, and FSH. Estrogen, progesterone, LH, and FSH. Yeah, they also try and remember what inhibin does. What's happening in each phase, what's happening in the follicular phase, what's happening at ovulation, what's happening at the luteal phase, and then, of course, what's happening in the uterus as well. Okay. Right, so I shall go through it. Yes, I shall go through it. So remembering what happens at the beginning of the cycle. So there's no FSH on this slide, so I do apologize for that. So the beginning of a cycle, FSH levels start to go up. As those FSH levels rise, they stimulate follicle growth. So it's follicle stimulating hormone. They stimulate the development of the follicle. One follicle develops primarily, so the primary follicle, and that's the one with the most FSH receptors. The others will die. So that follicle produces inhibin, which again is inhibitory on FSH, but also importantly, it produces estrogen, and that estrogen further develops the follicle. And that one follicle keeps developing and developing and developing until estrogen levels become so high and the follicle is ready to release its egg that the high estrogen has a positive feedback loop onto LH and you get an LH surge. The LH triggers the egg release. So you can see in this image, you can see the estrogens going high, the LH surge, and that LH surge triggers ovulation. LH also triggers the formation of the corpus luteum, which is now secreting high levels of progesterone. So the endometrium is completely and lovely and ready for implantation of a nice ball of cells, so a fertilized ball of cells. But if implantation doesn't occur, luteinizing hormones levels will drop, causing progesterone levels to drop, meaning the endometrium can no longer be maintained, and we start to get breakdown of the tissue, release of the blood, and you get menstruation. And then you've got low levels of estrogen and progesterone, so FSH can start to rise again. Okay, so hopefully that is nice and clear in your minds. Yeah, hope you enjoyed.